A solenoid has 75 turns, is 15 centimeters long, and has 2 amps of current. Find the magnetic field inside the solenoid, A. Find the momentum of an electron circling inside the solenoid with a diameter of 5 millimeters. Which direction is the electron circling? So here's an overall sketch. This is the solenoid showing the current coming in at the top and coming out at the bottom. Using the right-hand rule, the B field is upwards as indicated. The top view, looking down onto the top of the solenoid, would then show the magnetic field coming up out of the page. The current is going around this way in the wire. And the cyan circle is the electron circling. The right-hand rule applied between V and B would be pointing outwards like this, but the force is reversed with the negative sign of the electron inward, which is the right direction. And so that means the direction for V as drawn is correct, and therefore that the electron is moving in a counterclockwise fashion around. So now to find the magnetic field inside the solenoid, we can use the formula for a uniform field inside a solenoid, B equals mu naught N I, where mu naught is the magnetic permeability, N is the number of turns per unit length, and I is the current. 75 divided by 0.15 meters, and that works out to 1.25 times 10 to the minus 3 Tesla. In other words, 12.5 Gauss. And in order to find the momentum of the electron, we can use the formula relating radius momentum to charge and magnetic field. We can solve this for momentum. mv is equal to qbr. The magnitude of the charge on an electron is 1.66 times 10 to the minus 19. The b that we previously calculated, 1.25 times 10 to the minus 3 Tesla. The assumed radius of the electron is 5 times 10 to the minus 3. I see now that this is diameter, so I'm going to change that to radius so we don't have to recalculate. That corresponds to an MV of 1 times 10 to the minus 24 kilogram meters per second. What's the speed corresponding to that momentum? Well, we could simply take the momentum and divide by the mass of the electron, 9.11 times 10 to the minus 31, and conclude that the electron was moving 1.1 times 10 to the 6 meters per second. Not yet relativistic, but on its way.